Ooh, that sugar sweet, you got what I need. Sipping on the potion, all that good emotion, just my kind of heat. Keep it on repeat, tested by the potion, loving this devotion. Live it up, live it up, live it up, sweet emotion. Every time, every night, you and I on a roll. Switch it up, switch it up, switch it up where I'm going. Stay on the fly just in time, know the right way to go. I'm on the road, it's my time, taking control of my life. I want to run the red lights, I've got to run this show. You always take me so high, you always make the highlights. I love the way we vibe, you're like a centerfold. Ooh, that sugar sweet, you got what I need. Sipping on the potion, all that good emotion, just my kind of heat. Keep it on repeat, tested by the potion, loving this devotion. Ooh, that sugar. All I want is satisfaction. Make a move, baby, you got nothing to lose. Give me that, give me that, give me that good reaction. Gonna make it right, little like an offer I can't refuse. I'm on the road, it's my time, taking control of my life. I want to run the red lights, I've got to run this show. You always take me so high, you always make the highlights. I love the way we vibe, you're like a centerfold. Ooh, that sugar sweet, you got what I need. Sipping on the potion, all that good emotion, just my kind of heat. Keep it on repeat, tested by the potion, loving this devotion. Ooh, that sugar Ooh, that sugar Ooh, that sugar sweet, you got what I need. Sipping on the potion, all that good emotion, just my kind of heat. Keep it on repeat, tested by the potion, loving this devotion. Ooh, that sugar, just my kind of heat. Ooh, that sugar.
Hey everyone, and welcome to Monday night Monday Night Cat. I almost said Monday Night Lure Lab. Hope that everyone is doing great. I myself am doing good. And today we are going to make a lure holder so that when I'm, for example, when I'm painting multiple lures, let's say I want a way to hold it and I want a way to store it. I know that there are already ways to do that. I've seen some of them using pipes and stuff like that. But so here's the thing. So I did this stand. It's right behind me. I don't know. It's out of focus. But anyways, it has a bit more paint on it now. But I might do another one also, and a smaller one though. And instead of putting the paint, maybe I can hold the lures. So let's say I'm painting like 10 lures, for example. It's easier for me to just hold them somewhere. So that is the plan. I already have a general idea of how it's gonna look like. I'm talking about the thing itself that will hold the lure. And yeah, this is what we are going to do today. So I have an empty FreeCAD document here. I'm going to create a part. This is what I'm doing right now. I always start by creating a part. I think it makes things a lot easier going forward, because like before that I was just starting to add bodies and then things could get messy, but now I'm forcing myself to create a part first. So yeah, this part is currently active. That's why it has the what is this? Magenta, pink, purple, lavender color. Yeah, so I'm gonna create a body. Let's call this part the lure holder, or it could, what could we call it? Like lure pin, lure. Let's call it lure holder. Later on, for example, we'll create a new part, and that will be the part that will actually attach to the stand. But for now, let's make something that we can hold the lure from, let's say, from one of its hook hangers using it. So, and I think it's gonna be something like, so if we look, can we say lure painting holder? Nah, not this, not that. Something like this, but without the screws. So you'll see. You'll see what I have in mind. Yeah, something like that. So this is very similar to the concept, basically. You see these cutouts, and then there's a screw that will force these 3-4 parts to collapse, and they will hold the lure. Hopefully it's going to be strong enough, because it's going to be plastic. But yeah, and as always, there's going to be spreadsheets, the boring stuff. I think for this lure holder we'll only need one spreadsheet, but so I could not rename it, but I like to also rename stuff, like for example lure holder params. So here we will have the parameters for our lure holder, and from the top of my mind I'm just to a diameter and a length for now, and then we'll get back and start adding more. So let's assume the diameter is what, like 15. Again, might change it. Let's go with 20, and a length of 120. Also, I'm starting to add the units to these. Make things also not easier. I wouldn't say easier, because I could just say 20 and it will work. But yeah. This will make sure that this is actually a distance. We're gonna name this diameter, and this one length. Cool. Diameter and length. So I think I'm gonna have it standing up. So I'm gonna go to the top, and that's one of the reasons I created a part. So let's call this the main body, for example. And we're gonna need a couple more bodies in a minute to do Boolean operations, because the thing with bodies is every single body can only have one solid inside of it. So if I want to do Boolean operation between two solids, I must have two bodies, basically. So we're gonna start by creating the most simple shape possible, which is gonna be a cylinder. By the way, we don't even need a sketch for this. Technically, let me show the origin. Technically, I can attach a cylinder from here. Attach it to the XY plane. Give it a radius, which is going to be lure holder params dot diameter divided by 2, because we need the radius. And the height is going to be our length. Cool. We didn't even need the sketch for that. And now we are going to create another body. Let's call this body. That's fine. It's active. Make sure it's active. That's important. And what I'm thinking, because I could leave it as a cylinder, but it's not gonna be strong if I print it standing like this. Like I print it like that, it's not gonna be strong. It's gonna be brittle because there's gonna be layer lines and we're relying on layer adhesion. There's some intricate parts here, so yeah, not ideal. So that's why I want to do a Boolean operation. So with this body activated, what I'm thinking about is to create a box on the XY plane. So the height is going to be the same height or the same length. We called it length, I think. Okay, so it's not centered. We will fix this. 1 second. Width is what? Width is up. It doesn't actually matter. So one of these will be equal to the diameter. Let's see. Lure holder params the diameter. And actually, you know what? I'm gonna add 1 millimeter, just in case. You see what I mean in a bit. Let's leave this as 10 for now, and then we'll get back to it because I don't know yet exactly how it's gonna be. But assuming this is 10, we need to go here by -5. So it's in the middle, and in the Y direction, we need to go by minus. Basically, the value we entered, which is lure holder params, the diameter plus 1, and then we divide it by 2. Mil. Cool. So this is not necessary, the gap here, but yeah, it doesn't actually matter. Now here, I want to know how much do I want how much do I want to cut, because I want to do a union. We're gonna do a union operation between these two, and I want this to be something relative to the diameter. So maybe like lure holder params, the diameter multiplied by, I don't know, 0.8 8 probably. So we can take this value here and we can turn it into a parameter like let's say cutout percentage maybe. And can we do percentages here like 80%? Does it work like that? I've never tried this, so we will figure that out. So if we multiply this by lure holder params dot percentage, cannot convert str to no. Okay, so it took it as a string, not a value. I guess, yeah, I guess this is gonna be like 0.8, right? Or what I can do, which is even better, cut out length and then say this will be equal to length multiplied by 0.8. And then we can use that here. So that's gonna be, forgot to change the name. That's not even a cutout. Let's rename it. Let's call it box length, because the actual cutout is different. So that's gonna be the box length. Interesting. I took the length. Oh my god, it's diameter. And in the x direction, there's going to be minus the box length divided by 2 to center it. And now we have these two shapes. And if we go back to the main shape, we can create a Boolean operation. And we need to add our body and get the common value between them. So this is going to be much easier to print because I can put it on the bed this way. So basically it's printing like that horizontally. It's going to be easier to print and much faster. Easier, faster, and stronger also, which is always nice. Cool. So what we need to do is to also create a cutout somewhere here. We need to create a cutout. We need to add threads. And we need a way for whatever being threaded here to close this part. Yeah. I'm thinking now because maybe I shouldn't have done a cylinder. Maybe I actually needed a sketch that goes like that, but then here at the end it goes this way. Probably. We can still add it though. Let's delete the Boolean for a second. I'm gonna hide this. Yeah, let's hide it for a minute. We can still add it by... We can make a bigger cylinder, extrude it downwards and change the angle. We don't have too much control over that. Or we can make two cylinders and loft it. That's one way. Or we can draw a profile and revolve it. So there are many ways. But do we still need this cylinder? Okay, let's delete the cylinder and start from scratch. We actually needed that. My bad. Okay, so the total length is going to be our length. Cool. And we need the basic shape of the cylinder, the side profile of the cylinder, but not all the way up. So this right here is going to be half our diameter. Which is in this case 10 millimeter. Cool. Okay, so here's the tricky part. I was thinking something like that. But how much is it and what is this angle? So the angle, I think we can go with 45, maybe even less. And do we need a fillet? We can chamfer later actually. 45, maybe it's too extreme. Maybe something like 70. And I guess we can do something here like lip angle. Set it to 70. I think we need that. 70. Yeah. That's how you set it in degrees. So this is going to be our lip angle. Cool. And the only thing that we need to define right now is this length. So let's call this the top diameter. And maybe 22. Yeah, so this is gonna be our top diameter. Yeah, and we don't need much, by the way. I think like even 1 mil could make a difference, but we see, and maybe we need to reduce the angle. Maybe 45 was fine. 50. It's not updating. Huh, something is wrong. Oh, yeah. That's top diameter divided by 2. Okay, that's why. Yeah, I'm gonna leave this at 70. That's why it was weird. So this is what's gonna push the two parts together, basically. Or at least that's the plan. Now we can revolve this 360 degrees. Maybe we can make the angle even bigger, like 80. So it's gradually going down. It's looking nice, not bad. So now we need to modify our box. Because, first of all, show me the box. Because now this is bigger, so we need to width. Is it width? We need to get the top diameter now. Top diameter, there's a unit mismatch. Yeah, this should be millimeters. Width is top diameter. And we need to change something else, which is here. Yeah, top diameter. Cool, now it's centered, nice. Now we can come here and redo the Boolean operation. Boolean, add the body, select the body and set it to common. Cool. Nice. So let's now define the cutout length. Do we need to create one cutout? I think, yeah, because it's gonna be printed on one side, so cutout should be here. So cutout length, let's do, whoops, not here. Let's do 2 mil for now, and we will modify it in a bit. And this is the, what am I clicking? Ah, come on. Here, yeah. Now we're fine. Cool. So we want to draw a sketch here. So I'm gonna create the datum plane. Create the datum plane, attach it to XY plane, and in the Z direction, we will go by the total length. And let's draw a sketch here. This is a very simple sketch. So a centered rectangle, centered around the circle. This right here is going to be our cutout. So cutout length. And now the length of this one, let's just set it to the diameter. Roller params dot top diameter, and just because why not, we can add 1 mil. Doesn't matter. Close. And let's say we need a cutout depth also. Let's make this one 6 mil, probably more, 12 mil. And the cool thing about parametric design is I don't even know if I need these values to be correct. They don't have to be correct at the moment because I can change them at any time. And I like that. So cutout depth. Nice. Nice. Now this is probably too thick and we might need to reduce the diameter or increase the cutout. Something like, let's say 3, and we have a top diameter. Actually, you know what? The top diameter, I'm not gonna calculate it like this. I'm gonna put it somewhere here. And let's call this one top diameter offset, for example, and set it to 2 mils. This is not gonna change the actual value, but it's gonna be like, it's gonna make more sense. So this is gonna be diameter plus top diameter offset. It's still 22 mil, but we have an offset now. So why did I do that? Because now if I change this to, let's say, 14, change it to 140, 14 mil. The top diameter is now 16. So I maintained the 2 mil difference between these two. This looks more realistic now. These two will bend a bit and should work. Cool. So now we need to create the thread and the screw. That should be it. It should be a simple print, theoretically speaking. Now I can do everything in one spreadsheet, but it might become a bit slow. So especially the thread part. So I'm gonna create a spreadsheet just for the threaded part. Because every time I work with threads, it just becomes slow. Let's say lure holder thread params. So for thread, what do we need to know? We need to know, let's say, the length of this thread. So let's say it starts from here all the way up here, for example. I think it should stop somewhere below this, because if we add threads here, it's going to reinforce this section. So it might not bend well. But anyways, let's define a thread length. Let's say it's 30. Whoops, giving it an alias. Why am I clicking all over the place today? Thread length. Oh god. Man, I used FreeCAD millions of times and now I just forgot how to use spreadsheets. Yeah, so thread length, and probably I'm gonna start the thread right after the cutout, so I don't need a param for that. Maybe offset from cutout so we can control it. So I can set it to 0, I can set it to minus, so let's say 2 mil, for example. So the thread will start 2 mil from here, somewhere here, and then it will extend 30 millimeters down. And usually I like to create these threads as a circle, so let's give it a threading diameter, for example. Whoops, it could be like 2 mil. Again, we can control these values, so that's fine. And let's add a tolerance of 0.2 mil. That's the threading diameter, that's the tolerance right here. Cool. Thread length, offset. I think that's enough. So the thread will be here. It's gonna be like a reverse of what you usually see on bottle caps. No, actually it's the same. Anyways, let's draw the profile of the thread. It will start from this edge, for example. Now I'm thinking if I do a boolean or not. Yeah, I think the boolean operation has to be the last thing. So I'm gonna delete the boolean and hide it for now. So this is gonna be like a perfect circle. We're gonna do the thread and whatever changes we wanna do here, and then we do the intersection. So let's create a sketch here. We're looking at it from the right. I don't think it matters. Yeah, it shouldn't matter. So we are going to create a circle. This circle will have a diameter of lure holder params or thread params, threading diameter. And where do we want to put this? So we know that the distance from here till here is basically our diameter divided by 2, the radius. So now we cannot move it left and right. And where do we want to start? So let's go from here to here on the vertical distance. we want to go up by the length, so the full length minus. We need to remove the cutout length or cutout depth. Oh man, these names are confusing. Sorry, my bad. This should be height and this should be depth. And there should be no length. This should be width. Anyways, and we also need to remove from the thread params the offset from cutout. And I have a typo here. Let me fix that. Cool. So now this should be exactly 2 mil away from this line because this is what we specified here. So if we close this, I just want to remember that it's on the right side. Looking at the right side, it's on the left of the thing. Cool. Now we can create an additive helix. Okay. I thought it failed, but it didn't. Yeah. So we need to reverse it so it goes down. Nice. And we have pitch height angle. Height times angle. Pitch turns pitch height. I think, yeah. We have the height, we're missing the pitch. So let's set the height for now. And this is called thread length, which is going to be 30 mil. And regarding the pitch, yeah, this is gonna be a param. So I'm gonna set it to whatever for now. And then let's create pitch, and I should save now. Let me save because we're getting into dangerous territory. Let's call this painting accessories because we might add some stuff later. Lure painting accessories, copy that, save it. Let's do a pitch of 4. So you see, whoops, no. You see it's getting slower, this spreadsheet, and that's why I decided to create a new spreadsheet instead of adding the values here in this one. This should be fast now. Like, for example, if I set this to 10 or not. Anyways, we haven't applied the pitch, so let's do that. Set it to 4 or whatever the value in the spreadsheet is. And now we have our screw or our thread. We haven't created our screw yet, which we will do. So for the screw, I think that's gonna be all for this section. So I can just go ahead and create the boolean, add the body and get the common and hit OK. Yeah. Yeah, we have a problem here. We have a slight problem here, which we might be able to fix in a bit. No, actually, no. No, we don't. Because I can just print it on this face. This will not work. Because of this overhang right here. But if we print on this face, we're fine. Cool. We don't have to do anything. Nice. Now we need to create the screw, so we need a new body. Create a new body. Let's call it screw or lure holder screw. We should rename this, but it doesn't really matter at the moment. Lure holder screw. I want to move this up here. I'm thinking though, if I start it from down here, or do we start from the top? I think we should start from the top. Yeah. So let's just move it by, we can change that if it didn't work. So lure holder params length, which should be height. And now we're up here. Okay. Okay, and do I need to add the tolerance? I don't think so. We can add it also. I think we're fine. So regarding this screw, we are going to do a similar thing to what we did with the base profile of the cylinder, where we had to draw this. Something like that. And this one go here, and this one go here. Now the biggest problem is gonna be the threads. Because the threads should... No, it's not gonna be like that. Because we need thickness. We need to draw another. Yeah. Let's close this. That is fine, but let's create a new spreadsheet. Or we can do it here. Let's do screw thickness. And let's do it as a 2.4 mil. I think the threading at the moment is too thick, so I might change it. So if you come here, thread diameter, it's 1 mil. And if you look at it, it's thick. Maybe we can make it 1. To click enter to not work. If you just click outside. Maybe we can increase the pitch also. So we can double this, I guess. Or let's go with 6. Oh, sorry. We need to decrease this, not increase it. So 2. Yeah. Something like that. Now, the thing is, we're gonna have a thickness. So if we come here, we have some constraints. Wait, this one. If we remove that, yeah, so these two are together. And this one is here. These two are together. Whoops. And this one is horizontal. Cool. This might be a bit tricky to do here, this section. But let's this is going to be lure painting params dot thickness. We need to add tolerance somehow. So thickness, do we add it here? I didn't add tolerance there. I added in the threads, right? And the angle here, if you remember, was where is the angle? This was lip angle. And this here is the lure holder params dot top diameter minus no wait, it's top diameter divided by 2 plus the thickness plus tolerance. Wow, that's too much. And now we need to basically just define, whoops, what's going on? We need to define this from here to here. So to make things easier, I think I can calculate this. This is cut out, so let's close it. So the length from the cutout till the end of the thread, we can put it somewhere. We can put it in the thread params because here we have easy access to thread length. We can add a value here. Let's say this is equal to cutout depth plus offset from cutout plus thread length. And let's call it here. What do we want to call it? Length from top to thread. These values will make things a lot easier. So if we come here, the distance from here to here is the length from top to thread plus the thickness of the screw. I don't think we need thickness here, but why not? We're adding thickness everywhere. Plus the lure painting params, thread params, tolerance. So this way it hides the screw when it's closed. But actually, no. No. We don't need that. Yeah, I messed up a bit, even at the top. I messed up a bit. Because even this, I don't think it should be like this. The only place we need to add thickness is on the sides. I don't know why I did it like this. Yeah, my bad. So this is gonna be here. Okay. This is going to be here, and here we need to add thickness. So distance here is going to be lure holder params dot diameter plus diameter divided by 2 plus lure holder params dot screw thickness, and we also need the tolerance. I don't know why I'm slow today, but it is what it is. And here's the thing. I can do this, so I can close this now and revolve it. Hit OK. And then, for example, I can click these two down here and where is it? Thickness. And give it a thickness. This will work. but it's not gonna be parametric. Oh well, yeah, it has to be inwards. My bad. It's not gonna be parametric, and this value is wrong. It's lure holder params dot screw thickness. Yeah, that's the actual value before cutting out these two. So yeah, this will not be parametric. If I change some stuff, it will definitely break. So how do we fix that? What is this? Why did it do this? Anyways, let's cancel. Another way is to create a new sketch. So let's create a new sketch on any plane and redo what we did. But this time we are going to trace the edge. So down here, here, up here. This is an easy one. Length from top of thread. This is also an easy one. This is the lure holder params, the diameter divided by 2 plus, we're only gonna add tolerance here, not thickness. And the angle will always be the same. So the angle here is the lip angle. And this one is also an easy one, which is the top diameter. So you see, it's not that bad. It's a bit of extra effort to make it parametric, but it's not that bad. Yeah, that's it. Now we can revolve, but we'll use the groove, which is like a negative or an opposite of the revolve. It will cut. And now we can see we can measure it actually from here to here. It's a 0.2 mil, which is our tolerance. Clear dimensions, and if we measure from here to here, that's 2.4, which is, I'm guessing, did I put 2.4? Yeah, screw thickness. Cool. All what is left to do is to create the cutouts for our screw. So we are going to create a sketch. It was starting from the right side, right here on the left. I think this is what I remember. So the center of this circle has to be the exact center of the old one. So we don't want to use any tolerances or anything here. So it's just this way. It is going to be lure holder params dot diameter divided by 2, and this way it is going to be lure holder params dot cutout depth plus lure holder thread params dot offset from cutout. And I made another typo. So as you can see, this circle is exactly in the center. Now the diameter here is going to be whatever the diameter of this circle was, which is the threading diameter, but we need to add tolerance multiplied by 2 because we're dealing with the diameter and not the radius. Cool. Now we need to use the subtractive helix and it has to go in the reverse because as you can see it's trying to go up, so we need to reverse it. And let's start with the height. This is going to be the thread length, and the pitch, it might take a while to calculate. This is going to be the pitch. Now we need to validate that, yeah, you see, it's like that. It should be like that all the way through. So if we hit OK, we can do a section view. Huh, it failed. Why did you fail? Subtracting the helix failed. This is interesting. Why do you fail? It should work. Theoretically. Huh. Interesting. Okay. It is not liking that. Cancel. Nothing wrong with the sketch. Nothing wrong with it at all. What we can do, is we can create a new body. Maybe I should have created a part here, but anyways, I can create a new body. Let's make it active. And let's draw a sketch on this plane. We have to redraw the, I'm just testing something. It might not work, it might work, but let's see. I want to redraw this circle. Let me hide it though, so it's not distracting. Now we're doing it from the bottom. So from here to here, that's going to be diameter divided by 2. I don't know why the thread failed. Usually it doesn't. Usually it works. So take the length, remove the cutout depth, remove the offset from cutout, and I missed something, right? No? Why? So it's length. Did I add instead of, yeah, I added. Should be minus. Cool. And now the diameter. Diameter plus tolerance multiplied by 2. Nice. And now we can do an additive helix. So let me hide the screw just to see what's going on. We want to go downwards and do the exact same thing. Let's do the height first. The thread length. And the pitch is going to be pitch. So these should match, and they do match. Click OK. Okay, so if we take the screw, make it active, and do a Boolean, and let's cut. And it failed. Why? What the hell happened here? Boolean with body 3. It is not liking that helix. Is it because of the origin? So if I move this body up to up here, and now we modify the sketch. So we come down here to man, the FreeCAD has to resolve these stupid issues because sometimes it's just super annoying. Okay. So if we try to do it again, will that work? Where is it going? Like, seriously, why? Wait, did it work? Okay, so now at least it did not change orientation. Oh, wait. No. No, it's not the case. Why would it even move? That's so stupid. And why do I even have to do a boolean? Because we can just groove it or do the subtractive helix. Sorry. If we groove this, will it work? Or wait, let's try something. Let's try repainting thread params. Let's try increasing the pitch. Maybe that's causing issues. And this should be in millimeters, right? Okay. So if I take that sketch and do this, reverse it, recompute failed, wait. Okay, so I can do a helix, but the problem is with something here. Thread length and pitch. Okay, so it worked. Apparently not all pitches and lengths will work. So I guess we need to just experiment with it. If it failed, change the pitch. Let's hide the main body and see how it looks from the inside. Nice. And this will print nicely. For this part, I'm not super worried about the layer adhesion, so I'm gonna actually print it like this. Or the other way around, it doesn't matter. And these will print very nicely because they're not full circles. They're not even half circles. There's tolerance. Anyways, so that's the idea. I'm hoping that it works, and then we can design something to hold it in this thing, basically, and like put 6 lures, 10 lures, 20 lures at a time being painted. Now let's see how parametric this is. So I'm gonna save, and let's, for example, go and change the diameter. If it's completely parametric, nothing should theoretically break. So let's make this 12. Might take some time to recompute everything. It's finished. Cool. Now we have a 12 mil rod. Oh, I can't speak today. Let's change the length. Let's make it shorter. Let's make it 100. Cool, it worked. Nothing is breaking. I don't want to mess with the thread at the moment. Actually, you know what? Let's mess with the thread. Let's make this screw shorter. So thread length, let's make it 20 mil. Okay. Let's see if anything broke. No, all looks good. All looks good here. It's printable on both sides, actually. Oh no, this side is not printable. Only this side. I think that's always the case. Yeah, cool. How much time do you think this will take to print? I think it's going to be super fast. So if we export this, yeah, let's just export it like that. Okay, and then the screw. Export. Let's call this one screw instead of all of this. And I think I have a 0.4 nozzle at the moment. I removed the 0.6 because I was testing something. Okay, so you will be printed on this side and you will be printed on this side. This is Bambu Lab PG High Flow and I have calibrated it, but I think I'm gonna use PLA. I don't know yet. Yeah, speed is gonna be a problem. PLA is gonna be a lot faster. 27 minutes. Oh, even on PLA, okay. Layer time is what, 4 seconds? Layer time, 4.5 seconds, okay. Interesting. So I guess these will be printed like that. It's gonna be much better. I mean, in the actual real world scenario, it's gonna be something like this. Printing 6 at a time. In that case, we don't have the problem of the speed. Yeah, it's gonna doing 200 millimeters per second. So it's gonna actually print them faster. Then remember, each one of them I think was 20 minutes. Now 6 of them will be 40 something. Yeah, I'm gonna print this tomorrow and test it. It's too late to print anything at the moment because the printer is very loud and I don't wanna I don't want to disturb the neighbors. One thing we can do here is maybe we can reduce this 2.12. Yeah. Maybe we can make these bigger. So in the thread, we can make this like 1.4 mil. Hope this will not break anything. It didn't. Cool. Yeah. Huh. Oh no, never mind. That's not an issue. Maybe the thickness is too much. Let me see it in wait. Oh. I thought the live stream is is done. Yeah, we can make it thinner, definitely. So the thinnest part here, we have 1, 2, 3, 4, and some gap. 4 walls. Yeah, that's too. We can go thinner. Come on. Lure painting params, cutout length, thickness. Let's do 1.8. Let's export now. So this is the main. Place it. And this is the screw. Place it. And reload from disk. Yeah, we can also turn on Arachne. Nice. Yeah, this is much better. Much better. This piece right here might still be too thick to bend, or I might even increase the length of the cutout. We'll see tomorrow when I test it. We'll keep you updated. I will send this to my supporters on Printables so they can also maybe test it. I will send the FreeCAD files and or the models. We'll see. And once I'm 100% sure that it works, then I will release it on Printables so you guys can use it. And I guess that's all for today. Maybe next week we can do the holder. Not the holder, the thing that will go on the wall. Maybe I will do it before next week because I actually need it. We'll see. I don't know yet. But yeah, that's all. If you guys have any questions, now is the time to ask. And you can always send them on Discord. I think someone actually sent something on Discord. Throw the water, and tomorrow morning I'm going fishing. Chasing pikes. Use everything. Better to try more lures than just to try one and not catch anything because the fish are biting different lures that day. True. You never know what the fish are biting. Actually, I have a spinner that I don't use at all. I should be using it. Anyways, enough mumbling. As I said, I will test it tomorrow. Hopefully it's gonna work first try. If not, it's an easy update. just changing numbers. How boring. And yeah, see you all next week. Have a great night. Bye bye.